Alright guys, got a bit of a unique example here for you. We want to try to graph this rational function, but first things first, I'm going to try to figure out if I can avoid doing an oblique asymptote in this problem. Basically I want to check to see if it reduces down, in other words if x plus 8 actually divides in to the numerator. Because if it does, then that means that the graph is just going to be a quadratic with a hole in it, and that's kind of what I'm hoping for here. So what I want to do is I want to set up synthetic division. I can do synthetic because I'm dividing by a linear factor. So really to set up the synthetic, you take the coefficients of the numerator, what you're dividing by. Note here that we don't have an x squared term, so I'm putting a 0 as a placeholder in that location. And because we're dividing by x plus 8, if I were to set that equal to 0 and solve for x, the number that should go in the box up here is a negative 8. Alright, so to start synthetic division, you bring down the 1. Negative 8 times 1 is negative 8. I'm going to add those two together. Negative 8 times negative 8 is 64. I'm going to add those two together, which I believe is 15. And negative 8 times 15, again I believe is negative 120. So it works out to have a 0 remainder here. So negative 8 does divide in perfectly to this problem, which means that this answer that I have left over here is equivalent to the problem that I started out with. All I have to do is plug in my x's. So this is going to be x squared minus 8x plus 15 that's left over. Again, that's equivalent to my starting equation since negative 8 divided in perfectly. And then because negative 8 divided in perfectly, that also means that my leftover graph here is going to have a hole in it where x is negative 8, and then I have to plug in negative 8 for the x's here and find the y value. So let's go ahead and do that real quick. Just plugging in negative 8 for x. So I end up with negative 8 squared, which is positive 64. Negative 8 times negative 8 is positive 64 plus 15. So 128 plus 15 is 143. That's my y value. That's a pretty big number there. So when we go to make our graph, we'll kind of make it work, I guess. So what I want to do here is I basically want to graph y equals x squared minus 8x plus 15, and then stick a hole in there at negative 8, 143, and kind of a big number there. So the first thing I'm going to look for is when I make my quadratic, I want to know where the x-intercepts are. So I'm going to try to factor this with guess and check. Factors is x minus 5, x minus 3. So I have x-intercepts then at 5, 0 and at 3, 0. And it's also helpful to know where the y-intercept is. You find that by plugging in 0 for all of the x's. Ours is going to be at 0, 15. This particular graph does technically have an oblique asymptote. It just so happens that it is equivalent to the function. We haven't talked about oblique asymptotes as I'm making this video in class yet, so don't let that confuse you if you're watching this a little early. What else do we need to find? Oh, it'd be nice, since we have a quadratic here, if I knew where the vertex was. I want to review something we haven't talked about in a while. I want to review how to complete the square. So to do that, we have to separate the terms that have x's from the terms that do not. So I want to look at the middle term here, with negative 8x, and figure out what I need to add to this equation to create a perfect square trinomial. So to do that, you always take half of this, which would be 4, and square it, which would be 16. So I'm going to add 16, and then I'm going to take that 16 back away. So really, it's like I added nothing at all. So it's still the same equation here. I've just added a 0. But I've added a significant 0 in that I can now group these first 3 terms together, and they will factor as x minus 4 quantity squared, leaving the last 2 terms to be minus 1. So this particular quadratic has a vertex at 4, negative 1. And so, I got my hole, got my x and y intercepts, and know my vertex. I think I'm good to go ahead and sketch the graph now. So I'm going to come over here and make myself a little grid. But I'm not going to go crazy, putting little tick marks on there, because I just want to label all of the points that I'm going to graph. Alright, so I got my vertex. I'm going to call this right here 4. Come over here and put negative 4, negative 8. So I got my vertex at 4, negative 1. We'll call this point here 4, negative 1. I got an x-intercept. I'm going to label this point as 5, 0. And another x-intercept at 3, 0. Have a y-intercept at 0, 15. Keep in mind my axis of symmetry, the thing that cuts the parabola here in half, would be this imaginary line at x equals 4. Alright, so my graph is going to look like a quadratic, pretty much. Something like this. But, you got to imagine way up here, if you kept going for a good long while, you'd get up here to where you have, this hole in the graph at negative 8, positive 143. This graph's going to eventually get to where it passes through. Okay, so I really didn't plan this out very well when I was making up this example, but you get the idea there. Basically, sometimes you'll have equations that you will work out and they will reduce down nicely to where you have a hole in the graph, and what's left over is a function that we've talked about in the past. Now, most of the examples we'll look at in class are going to be linear by the time we're done. So basically, you'll be graphing a line with a point and a slope and then putting a hole in it somewhere from the factor that canceled out. Alright, just as this one was a quadratic, and again, I apologize for the 143 there. I didn't really think through the problem when I made up the example. It'll be okay though. So, got to review some fun stuff here, some synthetic divisions in there. Talked about how to find holes in a rational function. Again, reviewing how to find x and y intercepts, so I'm plugging in 0. Got to review completing the square here to find the vertex of a quadratic. And then, just reviewing how to plot points basically and connect them. So hopefully this was beneficial. Fourth example. I'm going to do at least